Okay, we're talking about continuity at a point. And we've got a piecewise function here, which I'm calling k of x, and it's equal to x squared minus a squared over x minus a, and x is not equal to a. And the other part of this is just constant a as long as x is equal to a. I think I should have said 8 here. Okay. So the first step we want to do is we want to go ahead and evaluate it at a. A is where we're concerned at. This is where the function needs to be continuous. This is kind of a tricky problem here, but if you actually just follow the steps, just like we've done in the previous problems, and just trust the math, you won't have any problems. But this here I've already actually got it worked out, so we're going to find out if a is actually equal to 4. But anyway, so the first thing we want to do is plug a in. Now, which one are we going to use? Well, this here says x cannot equal a, so we can't plug it into this. But this one says x is equal to a, and x is equal to, if x is equal to a, then our y value is 8. Then the next thing we're going to do, we're going to take the limit as x approaches a. Now we don't have to really look coming in from the left or coming in from the right, because it's just one point, and that's at a, that we're really concerned with. So we take the limit as x approaches a, so we do the direct substitution. Now if I do the direct substitution and plug a directly in here, I get a squared minus a squared. I get 0 in the numerator and 0 in the denominator, plugging a in for x. So what we're going to want to do is factor the numerator, and we get x minus a times x plus a, and it's over x minus a. Then we can cancel these terms out, get a new limit, even though this limit is still equal to our original limit. We get x as x approaches a of x plus a. Then we can finally do the direct substitution, plugging a directly in for x, and we end up with 2a. Now remember that this must equal k of a, and so since the limit is x plus a as x approaches a has to equal this, then what we do is we just set these both equal to each other. So 2a is equal to 8, and then we just solve for a, and you're done. But then I go ahead and take this a, which is equal to 4, and plug it back in up there at the top, just to kind of show you what our final product is here. So we plugged a, which is equal to 4, and plugged it in for a, so there's a 4 here, and then 4 squared becomes 16, and then we just put our 4's in right here. Let's take a look at the graph. So the graph of that function, believe it or not, is just a straight line, and this was the point right here that we needed to make sure it lined up with our graph. So this is just a point on the graph. Now this is where a is 4, and remember when x was equal to a, we got 8 out. You can come over here and then come straight across and see that this is where our 8 is located.